Stanford University.
Okay, welcome to CS 193P. This is lecture 5. I'm going to break away a little bit from my normal schedule of lecturing, and I'm actually going to do a demo both today and on Thursday. So I'm going to kind of split up what would be a long demo rather on Thursday, do a little bit of it today and a little bit on Thursday. So the lecture topics today, I got one last Objective-C thing to talk about, which is protocols. Okay, very important language feature that we're going to use in most of the assignments that you're going to do going forward. Today we're going to introduce views, which is the way we draw and get events on screen. And we're going to show you how to do a custom view. So that's a view that draws something specific to your application. It's not a button or a slider, which those are views also, but they're generic. And then I'm going to do this demo, and the demo is going to include a custom view and also protocols, this delegation feature using protocols, and also core graphics, which is how we draw. And I'm going to show you UI slider, okay, which is another UI button-like built-in thing in iOS. Okay, so that's what we're going to do today. So let's start out with protocols. Protocols are actually pretty simple. They're really just like @sign interface. Remember, @sign interface is the way we define a class, but there's no implementation and no instance variables. So really, it's like defining a class, but only the methods. All right? So that's what a protocol is. You guys are all familiar with other object-oriented languages. Every language pretty much has protocols. I think in Java they're called protocols, if I remember. So this should not be like, ooh, what's that? But mostly what I want to do here is go over the syntax of it, so you know what it looks like. So here I have an example protocol called foo. It has 3 methods: do something, and get many somethings. A method in a protocol is required unless it's preceded by this @sign optional. And just like we had the instance variables with @sign private and @sign public, you could say @sign optional and then list 4 or 5 methods. They'd all be optional until you go back to @sign required. So in this protocol, the first 2 are required. The middle one, get something, is not required. It's optional. All right, meaning you don't have to implement. You can still say you implement the protocol, but you don't have to implement this particular method. It's perfectly reasonable to have protocols that are all optional. And in fact, iOS has tons of those. Okay, protocols where every single method is optional because maybe you only really want to implement 1 or 2. So that's perfectly fine. You take the lines you see above this @sign protocol thing and you put it in a header file. And usually you either put it in its own header file, and you would probably call it foo.h in this case, the name of the protocol.h, or oftentimes you'll put it inside of a header file for a class that wants to use that protocol, or it wants some other object to use that protocol to talk to it. Okay, does that make sense? You see what I'm saying? So like an object might be vending some service, it has a certain implementation of certain methods, and then it needs some other object to implement some methods for it. And so it'll define that in a protocol in its header file. And we're going to do that today. So it'll make a lot more sense when you see it in the demo. I put the example here, UI scroll view delegate protocol. That's defined in UI scroll view.h. And I'm going to use scroll view as my canonical delegate throughout these slides here. So you have this protocol. Now we know how to specify it with @sign protocol. And then some class implements that protocol. Okay? Now, any class that wants to implement that protocol has to proclaim that they are implementing that protocol in their @sign interface. And you see the syntax here is that little angle brackets foo at the end. That means this class, called my class, inherits from NS object and it implements the protocol foo. Okay? Now, it's proclaimed this, and so now the compiler is going to make sure that it actually implements the required methods in that protocol. Okay? It's going to actually check it and complain. And the compiler will complain if it doesn't implement them. All right. Now you can have multiple protocols. You would just put them with commas. So angle bracket foo, comma bar, comma whatever, close angle bracket. And it's quite common to have an object that implements multiple protocols, especially controllers. Controllers tend to implement quite a few protocols. Okay. As I said, you have to implement all non-optional methods. So now that you have this protocol declared and you got some objects implementing it, hopefully, you can now declare variables of type ID and further require them to implement a certain protocol. Okay, so now you can see the value in this. ID normally is an object of any kind. You could send it, pretty much any message. It might crash at runtime. Here, you're giving the compiler an opportunity to check to make sure that that object might respond to this message by saying, in this case, obj is an object of some unknown type that implements the foo protocol. So here we're declaring a variable, obj, which is of type ID implements foo. Okay? So if you did this in the compiler, that first line, the compiler would be like, hey, no problem, because we just saw that my class implements foo, and so my class alloc init returns an instance of foo, and so this assignment is perfectly fine. But the next line would not work. Okay, compiler would complain, NSArray does not implement foo. That's what it would claim, because NSArray doesn't implement foo, right? And yet we assigned it to a variable ID that implements foo. Everyone make sense? Okay, yeah? Yeah, the question is, if I wanted an array that implemented foo, could I subclass NSArray and implement the methods in foo? And absolutely I could. And then this line, I'd have to assign it to my subclass of array, an instance of my subclass. But yeah, you couldn't do that, absolutely. Okay. In addition to declaring variables, you can also declare arguments to methods, so that the method takes an object as an argument that implements foo. So here I have this method, give me foo object, and it takes as its only argument an object that implements foo. That's what ID angle brackets foo means. Okay? Pretty straightforward. One thing to notice in all this, this is just like static typing. This really has no effect on what's going on at runtime. This is just a way to get the compiler to make sure you haven't made a mistake in your code. Typed a method name wrong, you designated an object to implement a certain protocol which doesn't, that kind of thing, okay? So this is purely just compiler helping you, syntax. I like to think of protocols as documentation for your method interfaces that's built in and checked by the compiler, as opposed to documentation that you type in a comment that gets out of sync after a few revisions. This way, you got to keep it in sync, otherwise the compiler's going to start complaining, oh, this object doesn't implement that method or doesn't implement that protocol. So it's kind of like documentation. The number one use of protocols in iOS is the delegates and data sources we saw in that MVC picture I showed you on the first day. Okay, so this is an object that a delegate or data source is an object that implements some methods that the other object wants somebody to implement. It doesn't care who, doesn't care what class of object implements it, but it needs those methods to be implemented. Or may not need them, but if someone is interested, they can. A lot of the wills and dids, it doesn't really, scroll view doesn't need will scroll to point to be implemented, but if somebody wants to implement it, now the method is declared and documented in the interface so that everybody knows what's going on. One thing to notice here, delegates and data sources are always properties, and they're defined as assign properties. You see that little parentheses, assign, not retain, okay, or copy. It's assign. And this is something that people are scratch their heads over. But the primary reason for this is usually the delegate in iOS is going to be an object that owns you. Most notably, you're a view, like UI scroll view, and your delegate is your controller. Okay, and your controller created you from your zip file, right? They loaded up this zip file and created the scroll view, so they own you. And so the controller is guaranteed pretty much to live longer than the view, because it created the view and it's also going to destroy the view at the end. Okay, so you don't need to retain a pointer to it because it's always guaranteed to be there. So there's other reasons to make this assign versus retain, but this is the convention, and it works out pretty well. Okay. Now, if you had a protocol where you had a delegate that you're not sure it was going to live longer than you, might be some specially created object to do something, you might want to rethink this, doing it this way. But this is how you declare the property. So it's just, again, same kind of property, ID, angle brackets, the protocol, and then the name. Okay? So let's take a look at scroll view delegate as an example. So the UI scroll view delegate protocol has about 8 or 9 methods in it. They're all optional. Okay, I put a couple here as an example. I don't want to put them all up here because we need slide space. But scroll view will begin dragging, gets sent when the scroll view starts to drag. Someone touches down and starts to drag. And when you let up, your touch from the dragging, it sends you the scroll view did end dragging with will decelerate, which is whether they drag with a little flick. You know how it accelerates and decelerates when you scroll through things. So these are just examples of what the scroll view delegate is like. Now, the scroll view object will allow somebody to specify themselves as a delegate, and then the scroll view will send these messages, whichever ones they implement. They're all optional in this case, so whichever ones you happen to implement. And of course, it's going to use introspection to make sure you respond to the method before it sends it. So here's UI scroll, a little piece of UI scroll views header file. I've taken everything out except for the property. You can see it says property assign ID, US scroll view delegate. So now let's say I have a controller, my view controller, right? It inherits from UI view controller, and I'm going to say that I implement UI scroll view delegate. Okay, and I got to put that little angle bracket thing. You'll forget to do that a lot, and the compiler will complain that your object doesn't implement that protocol, and you're like, oh, I forgot to put it in the @sign interface. So you have to implement the method you want, but you also have to put this, so the compiler knows that you intend to implement this protocol. Then it's really simple. You just allocate your controller. Here's my view controller alloc init. Init is the designated initializer for view controller. Then you've got a scroll view from somewhere. Maybe it came out of a nib file or something like that. And then you just say scroll view.delegate equals my view controller. Okay? So scroll view property delegate, you just assign it to my view controller. And since my view controller implements that protocol, all is well with the compiler. Okay? And then from this point on, anytime scroll view has one of these interesting things to say, it'll send it to your controller. Everyone got this? Okay? All right, so that's it for protocols and delegates. All right, views. So a view, just like in most graphical systems, and in this case by view I mean a subclass of UI view, like UI button, UI slider, or a custom view you might create, represents a rectangular area on the screen. Okay? So it defines a coordinate space basically on the screen. And then it draws in that rectangle, and it also handles touch events that happen inside that rectangle. Okay, so swipes and taps and pinches, it handles those, and it draws whatever it wants to inside that rectangle. The views are hierarchical, of course. Okay, you've got super views, and then inside you can have any number of subviews laid out however you want. They can overlap. They don't have to, be tiled or anything like that. A view can certainly have no subviews. Like I don't think UI slider, I don't think has a subview that I know of, but UI button does. It has a subview, which is a UI label, which is its title, right? So you can kind of build your user interface out of these rectangles that overlap and nest inside each other. That's the view hierarchy. It's pretty straightforward. This hierarchy you mostly construct in interface builder by dragging things out and dragging things on top of other things. And the hierarchy is usually fairly shallow. You're not usually going really, really deep. Although there's some places where you go fairly deep, and we're going to talk about those a little later in the quarter. And even custom views, if you just declare or write some custom view that draws something special just for your app, oftentimes you'll add that in Interface Builder too. And we'll talk about how to do that. We're going to do that today as well. It is possible to add views in code, and you do this as well. Sometimes you have a view that appears on screen, and then something happens with the user, and then it goes away and gets pulled out of the view hierarchy. Although a lot of times you don't pull it out, you actually just hide it, and I'll talk about that in a second. But straightforward methods in the UI view: add subview, which adds a view, and remove from super view. And now the thing to be clear about these two methods is they're sent to different objects, right? Add subview is sent to the object you want to put the view into. Remove from super view is sent to the object, the view you want to remove. Does that make sense? So you're not, you don't tell a view remove this subview from yourself. You send a message to the view you want removed and say remove yourself from your super view. Okay. You can also manage the order of the subviews. Order of subviews matters because they overlap, they show through each other. And so there's the insert subview below and above and at a certain index, so you can manage the layering of them. That's not very common, I will say. You're not usually doing that. So what happens, though, when these views overlap? So I got all these views, and they're all stacked on top of each other. It's the order of the views in a views subviews list, okay, subviews array, determines who's in front. Okay, the ones that are lower down in the list, higher indexes, show through the show through any transparency for the ones on top. So let's put it this way: subviews index 0 is at the top level, right? And all the other ones are in front of it. Does that make sense? And we're going to talk about how you get the transparency to happen and things overlapping and showing through. We're going to talk all about that in a couple slides. Yes, that's what I just said. So you also can hide a view at any time by setting its hidden property to yes. So if you say my view.hidden equals yes, it will not appear on screen. If it's in the middle of other layers, it'll just be like, it's not even there. It also won't handle events. Okay, hidden views don't handle events either. It's just like they're not even there. But it keeps you from having to remove them and then insert them right back in at the right place in the subviews, et cetera. You just say hidden and it's gone. Okay, and then hidden equals no, and whoop, it comes back. All right. Memory management. So let's talk about how you manage the memory of views. Very important to understand that a super view retains its subviews. It's just like an array retains the things inside of it. Super view has an array of its subviews. It retains them. All right. So once you've inserted a view into the view hierarchy, if you're not going to send messages to it, you don't want to talk to it anymore, you can release it. All right, because the view will take ownership of it. But you have to be a little bit careful when you remove a view from the view hierarchy. Okay, because the instant you remove it, by sending it removed from superview, it's going to release. It's going to be released by that view. Now, you might have retained it before then, hopefully, and so you'll be okay. It's not going to release it. But a lot of people say to a view, remove from superview, and then they try to send retain to it after that. And it's too late. After you removed it from superview, it got released. It got deallocated out from under you if no one else owned it. Okay? So if you want to remove a view from the superview, go get a pointer to it by, getting the subviews and, view index or whatever. Get a pointer to it, retain it, then remove it from superview. All right? IB outlets. Okay, I'm going to have a few slides on IB outlets here because we really haven't been doing this right so far, because we didn't know about properties, and so it's hard to really explain the right way to do it. But now we're going to start doing it right. First of all, you would think IB outlets, which are just pointers to views in the view hierarchy, right? Like that UI label display, we had an outlet to that in our calculator pointing to it. You would think, why are outlets even retained? Why do I have to have ownership of them? Because they're owned by the view hierarchy. Well, mostly they're owned for safety reasons, all right? Because you might have an outlet to a view, and then that view's superview gets removed, okay? And when that view's superview gets removed, it might get released and cause all its subviews to get released, okay? And your pointer to your outlet just got released, so that's no good. So that's why always IB outlets, interface builder, when it loads them up out of your zip file, it retains them, all right? And you always want to think of that model of your outlets being retained. But okay, if my outlets are retained, when am I ever releasing them, okay? And in the calculator, we didn't release our outlet, okay? Now, the reality is this doesn't matter that much because, for example, in our calculator view controller, which is the owner of our display outlet, it never dies. It lives the entire lifetime of the app, so it's never going to get released. And also, its view hierarchy never gets released. It stays on screen all the time. But as we get more complicated UIs where views are coming and going on screen, off screen, getting deallocated, new view controller MVC systems are coming online, and then they go away and they get deallocated, this becomes a little bit more of a risk. So we have to start getting in the habit of releasing our outlets at the right time. So when do we need to release our outlets, and how do we do this? Okay, so that's the next few slides are here. First of all, when we release them, obviously we need to release our outlets in the dealloc of our controller, because our controller is the one that owns those outlets, right? It has the retain that happened when they loaded from IB is really on behalf of the view controller. Okay, the view controller did it. So when the controller is dealloced, which you've never seen that actually happen because the calculator is so simple, but it will happen, we need to do it. But there's another time we need to do this, not just on dealloc. It is possible, though rare, that the view that a controller controls can be unloaded from the system. In other words, all its views completely freed, okay, released. Okay, when does this happen? Ostensibly, it can happen in low memory situations, all right? In other words, the view controller class is allowed when the memory gets low. If it's looking to recover some memory, well, I can just release all its views, as long as it's not on screen. Okay, if the views are on screen, it's not going to do that, don't worry. But if this controller happens to be off screen, its view is off screen, ostensibly can do this. Now, the reality is this doesn't happen very often because there's a lot of bigger memory fish to fry than those views. The views are very small memory usage. Things like images, sound files, these are gigantic memory users. And when memory gets low, we start hunting for those, to release those, the ones that we can recreate off the disk or whatever. We start releasing those. And we'll talk about that later in the quarter as well. Notice also that if a controller does dump all its views, it can just reload them from the zip file, right? That's why it has the luxury of being able to dump its views if memory got low. So how do we deal with that case? Because when those things are all unloaded, we want to make sure our outlets aren't leaking, right? Pointing to views, which will keep them. We're owning those views. They're keeping them in memory, probably keeping the whole view hierarchy in memory, actually, because the super view can't be released either. So view controller provides us a hook to do this. In fact, it provides these two paired methods. One's called view_did_load and one's called view_did_unload. All right, view_did_load is called on the view controller by itself. Okay, the view controller sends this message to itself as soon as the view is completely loaded out of the zip file and all the outlets are set up. Okay, so view_did_load is an awesome place to set attributes of your outlets or things that you can't set in Interface Builder for some reason. Maybe you want to have it point to some other object that's not in Interface Builder, or do something besides set attributes in the inspector. You want to do something else, and we're going to do that today as well. So view_did_load, great little method to know about. And then there's the other side of it, which is view_did_unload. That gets sent by the view controller to itself when it dumps the views for this memory management reason. All right, that's where, in addition to dealloc, we have to release our outlets. Okay, view_did_unload. Pretty much all you do in that method. But we're not going to release our outlets by just sending release to them. Okay, just to make it a little more complicated. Yeah, question first.
If a view gets unloaded when it's off screen and then it comes back on screen later, will it get reloaded first?
Yeah, so the question is, if a view gets dumped because it's off screen and there's some memory requirement that it gets cleaned up, and, its memory gets recovered and it gets dumped, what happens when it comes back on screen? Well, the answer is it gets reloaded from its zip file afresh. Okay, so that's why, and view_did_load would get called again too. So you get a chance to set them all back up again after they got all thrown out. Okay, so your view_did_load should also work if the views get thrown away and now get reconstituted from the zip file again. Again, this almost never happens, so mostly this is theoretical and I'm just trying to make sure completeness here so that you don't implement these methods incorrectly. But more important here is the syntax we're going to use to release the outlets. All right, so we're not just going to say release because we will make your lives difficult. No, not really, but just we want to document what's going on. So the way we do this is we create a property for every IB outlet. Okay, and this is what the syntax looks like. @ property retain IB outlet UI label star display. Okay, so in our calculator, this is really how we should have declared our property. We still need to have the instance variable too, because when we @synthesize this property, it's going to need to have that instance variable to store the pointer to the outlet in. But note, this basically does two things. One, it lets us use dot notation to get at our outlets, which is nice. And two, it's going to make it so that we're declaring in our API publicly, or even if we have this as a private property, that this IB outlet is retained. And we already know that's the case, but here we're writing it in code so that we are clear that that's what we're doing. All right? So it's kind of a documentation thing. You can put this @ property in your header file, in which case your outlet is now public. So other people could use that outlet, use that property rather, to get your outlet and start sending it messages. So be careful if you're going to do that. All right? Or you can put it as a private property. Remember I talked about how to do that using @interface, name of the class, open parentheses, close parentheses. And then you can kind of put private methods and properties there. We're going to do that today as well, so you can see how to do that, remind yourself how to do that. So now that we have properties for all of these, oh yeah, one thing there, just to be clear, Interface Builder will call the setter. Okay? So if you don't have the property like you have in calculator right now, it's not calling any setter because there is no setter. It's unarchiving it behind the scenes and just retaining it for you. But if you have this property, then it will call the setter. So you can put code in the setter. Although we're going to be careful about where we put code when we, putting code in the setter of an outlet. Sometimes it makes sense, sometimes not so much. We'll talk a little bit about that today. All right, so now that we have properties for all our IB outlets, how do we release them in view, did unload, and in dealloc? And the answer is we use this kind of funky notation, you might think it's weird, where we say self.myOutlet equals nil. All right? And I'm going to talk in the next slide why we do that. But notice that I've factored out that code into a new private method called release outlets, and I've said self.myOutlet equals nil, self.myOtherOutlet equals nil, and then in my view, did, and load, I call self-release outlets. You can probably imagine why I've done that, because I have to do the same thing in dealloc, right? In dealloc, I have to say self-release my outlets and then super dealloc. Okay? So that's why I always factor those outlets releasing into another method, because I got to call it from both these places. It's kind of silly, I know. Some people say, why don't I just call my view did unload from inside dealloc? And that's bad because it's semantically wrong. Okay? View did unload means your views just got unloaded. Dealloc means your object is disappearing, time to clean up memory. Okay? So even though they're doing exactly the same thing in this case, they're just semantically not the same thing. You would not want to call view did unload from your dealloc. It's just not right. Okay? It's not semantically correct. So how does this self.myOutlet equal nil work? Those of you who have mastered properties already in your mind can instantly see why this does the right thing and releases my outlet. But I'm going to go over it again because properties sometimes are a little hard to get your head around. So here is why. So I have this property, it's retained, I synthesize it. Okay? When I synthesize it, the setter that gets created looks like this. You'll remember this from last lecture, right? Display release. Display equals an object retain. That's because this is a retained property. But notice that first line right there. Okay? Display released. If I do self.display equals nil, then that first line of code, right, because an object will be nil, will release our old version of display, which is exactly what we want in our dealloc and our view did unload. So it's doing the right thing. Okay? Now it's going to go on to the next line. It's going to set display to nil, which is also a good thing. Because our view got unloaded, let's say, we release display. It'd be nice to be running around inside of our code when we're unloaded with display being nil, right? Not set to some bad pointer that has already been released. Of course, in dealloc it doesn't matter, but it's nice in view did unload. So we always do this is the bottom line. We always create this outside property, and then we do self.outlet equals nil in our view did unload and our dealloc to clean up. Okay? Questions about that? Yeah.
Somewhere in the docs that is it a good idea to have like if an object is not equal to display?
Yeah. So the question is in set display right there. Okay, I showed you the set display that is theoretically implemented by synthesize. It may be that synthesize, and so his question is it a good idea to make sure that an object is not equal to display before we end up going releasing it and then retaining it? Although it really wouldn't matter. Although actually it could matter, because if we're the last owner, it could release it and free it. So the answer is probably assign synthesize does that. It protects you against that case where an object in display. So you set the display outlet or this display property to itself. You wouldn't want it to release it, get freed, and then try and retain something that just got freed. That would be bad. Okay? So yeah, the synthesize takes care of that. When you have synthesized ones, it does the right thing, which we almost always synthesize our IB outlet properties, like 99.9% of the time. Okay, so that's it for views and IB outlet. Back to on views, that was about view memory management for views, including IB outlets. Now we're going to go back to view and drawing. Okay, so if we're going to draw, we have to have a coordinate system, and we need a few C structures that help us specify points and sizes and rectangles. Okay. Now, all of them inside the structs have what's called a CG float. Now, CG float is pretty much just a float, but we always use CG float every time we're talking about anything having to do with view geometry. Okay, it's type deft to the right thing on the platform you're on. So always use CG float. Never use float or double. CG point and CG side and CG rect are so straightforward, I'm not going to spend much time on them. They're structs that have the appropriate things inside of it. Rect, CG rect is a C struct that has one of each of the other two structs in it, a point and a size. That's how you specify a rectangle. And so these are just basic C structs. Now I'm going to talk a little bit how we use these structs to define a coordinate system. So the origin of a view's coordinate system in iOS is the upper left-hand corner. Okay, if you have any experience on the Mac, it's lower left corner, but on the iOS, it's upper left corner. So everything grows from the upper left corner. So increasing Y in a point means going down the screen, and increasing X in a point means going across. So for example, I put the point 400, 35, X of 400, Y of 35. It'd be somewhere approximately right there, right? It would be far over and only a little bit down. Okay? The units of these things is points. This is something new to understand with the new Retina display on the iPhone 4 and the iPod Touch. It's in points, not pixels. All right? So points are mostly what you want to use when you're drawing on screen, because a font's point size, you know, it's going to look about the same. A 12-point font looks about the same size on a Retina display as it does on an old iPhone 4, old iPhone 3 display. The only time pixels start to matter is if you're drawing something very detailed, or maybe you have an image that has a high resolution version that you want to show. Maybe you're doing 3D graphics or something like that. Then it starts to matter. And there is this property in UI view called content scale factor, which will tell you how many pixels per point. Now, you're actually going to need this for your next assignment, assignment number 3, because you are going to be drawing something very detailed, and you're going to want to draw it at the pixel level. You want to have as fine a drawing as possible. All right? So you are going to need this method, and it tells you how many pixels per point. Otherwise, everything that we're doing is in points. And when you start seeing the code I'm going to write to in the demo and stuff, you'll start to see, oh yeah, okay, I see. It's all in points. Now, views have 3 properties that describe their location and size. Okay, 3 that are important to consider here, okay? One is bounds. So it's a property, it's a CG rect. It describes the drawing area in the UI view's own coordinate system. All right? So the drawing that you're doing inside your view, or any manipulation you're doing inside your view, always with respect to bounds. Now, the bounds.origin, it's kind of up for you to interpret what your view means by that, because it has nothing to do with where you are on screen. Because this is your coordinate system, not your super view's coordinate system. Okay? It's the next two, the center and the frame. These two, rectangle and point, these are in your super view's coordinates. So they specify where you are on screen. Do you see why that is? Right? So if you want to know where you are on screen, your super view is going to say you're in this rectangle on screen. Okay? And its super view is going to tell that super view where it is on screen, all the way up to the very top view in the view hierarchy. And its location on screen is mapped to the entire screen, to the screen's location. So center and frame are used to position your view, not in the implementation of your view. That's the most important thing for you to understand. When you're implementing your view on its internal implementation, you're using bounds, the bounds property, self.bounds. When you're positioning your view, which actually your view rarely positions itself, usually someone else, like your super view or somebody else, positions you, they're going to be using the center and frame properties to position you, either setting your center to a certain spot or setting your whole frame, which would also set your size. Okay? Now, that's what I just said. Okay, so you might think that frame.size is always equal to bounds.size, right? Because someone says to you, you're going to appear in this particular frame on screen. Well, then my bound size is going to be the same. And the answer is, no, that's not true, because views can be rotated and scaled and translated within their super views. All right? So look at this picture right here. I got view B. Okay, its bounds are 0, 0, 200, 250. All right? So its bounds.origin is 0, 0. It's in its own coordinate system. It could set that bounds origin to something else, but mostly it's 0, 0. And you can see that it's 200 across the top and 250 down the side, right? We're talking about view B. All right? Now, its its frame, though, is in its superview's coordinates, view A's coordinates, 140, 65, 320 across the top, and 320 down. Do you see how that frame has to be bigger to enclose this rotated thing? It's like a diamond shape almost, right? So now the rectangle required to contain it is bigger. So that's the definition of frame. Frame is the smallest rectangle that completely encloses the bounds, right, in the subview's coordinate system. See how that works? So that's what the frame is all about. And you can see that the center, the red dot, is also, you know, some weird 300, 225, nothing related to the bounds in the superview's coordinate system because it's rotated, translated, etc. All right? Now, the middle of B, B's center in its own coordinate system is just bounds.size.width divided by 2 plus bounds.origin.x, comma, bounds.size.height divided by 2 plus bounds.origin.y, right? It's just taking its corner, going halfway across and halfway down. That's its center in its own coordinate system. Views are rarely rotated like this, but don't misuse frame and center by assuming that they're not. Okay? So make sure you're understanding when to use frame and center, which is to position views, and when to use bounds, which is in the implementation of the view itself. All right? And we're going to implement a view today, and we're going to use our bounds. We're not going to be using our frame. We'll set the frame actually in Interface Builder. You'll see that. So most often you create views in Interface Builder, even custom views. And the problem is that Interface Builder doesn't know anything about your custom view classes, right? It just doesn't even know they exist. You just wrote it today, so you can't know anything about it. So the way we put custom views into our overall view in Interface Builder is we drag out a generic view, and then we use the inspector to change the class of it from being UI view to being our subclass of UI view. It's that simple. And we're going to do that today. But how would you create a UI view in code, not in Interface Builder? Okay, we've already actually seen this before. You just use views designated initializer, or if you're doing a subclass of view, you might use its designated initializer. So for example, here I'm making a button. You can see it. Button does not have a different designated initializer than the one it inherits from view. So the way I create a button is I do UI button alloc, init with frame, the frame there where I want the button around the do it right there. Then I'm setting a property on the button, which is setting its title label properties text to do it. And then I'm adding the subview, in this case to window. We'll talk about window next lecture on Thursday. But window is just a view. And so I'm adding subview, and then notice I'm releasing the button. Okay? I evidently don't need to send any more messages to it or anything. I'm done with it. And I mean, realistically, probably I would have set up some target action on this thing, and there are methods for that as well. But I just wanted to show you an example here. You can create views in code and put them into the view hierarchy. It's not common, but it's done. It's not like it's really rare. All right, so when would I want to create my own view view subclass? Obviously, I want to do some custom drawing, or I want to do some custom touch handling. Like touch handling that's different than a button or a slider. It's, you know, pinching or something else, some special kind of view hierarchy. That's what views do. So I need a custom view if I'm doing a custom drawing or event handling. So the drawing, and so we're going to talk about touch handling next week. So today I'm just going to talk about drawing. And drawing is quite easy. You just create a UIV subclass and you override this method, drawRect. That's all you need to do. All right. So now we're going to talk about how do I implement that drawRect. But before I do that, let me give you this warning. You never call drawRect. Okay. DrawRect is not a method you call. It's a method you implement. All right. The way you get your view to get drawn is you send a message to your view, set needs display, or set needs display with a rectangle. All right. What set needs display do is it marks your view that needs to be displayed, and then around as the event loop runs around, and at the right time, iOS will call your drawRect. It'll set up everything you need to be, you know, graphic state, etc., to draw, and then it'll call your drawRect. Notice that drawRect has this extra little argument, which is arect. Arect is kind of a performance thing where inside your drawRect, you don't have to draw outside of arect. You have to draw everything inside that rect. But if you're only being asked to draw the lower right corner of your view and you've got something complicated in the upper left corner, you don't have to draw that. But anything that crosses into arect, you have to draw. And so set needs display in rect is basically saying, I need this part of this view to be displayed. And people might call that multiple times with multiple rectangles, and iOS will aggregate them all up and send a big rect to your draw rect that includes all of them. Okay, so iOS is pretty efficient about only asking you to draw the minimum number of times because drawing is expensive. All right, when you have to redraw your view, it's expensive. A lot more expensive than allocating objects and things like that. That's a lot more expensive. All right, so how do I implement draw rect? And the answer is you use the core graphics framework. The core graphics framework vends a C API. It's not object-oriented. There's some objects you're going to see here, but it's mostly not object-oriented. It's a bunch of C function calls. It's been around a really long time. Quartz 2D is the name of the core graphics engine. Been on the Mac for a long time. It's very efficient on lots of different platforms, and it works really well on iOS. They've really tuned it nicely. So how does core graphics work? So here's the concepts behind how you draw. First, you get a context to draw into, and I'll talk about that. Then you create paths, right? Lines and arcs and stuff. Then you set the colors and the textures or fonts or whatever you want, and then you stroke, meaning draw, or fill the interior of those paths. That's it. Okay, that's the concept. You just do that over and over to draw all the things you want to draw. So context, let's talk about that. The context determines where your drawing goes. So you're issuing all these C functions that drawing lines and arcs, and it's like that's got to go somewhere. And depending on where it's going to go, different things are going to happen. Okay, if it's going on screen, on a high resolution screen, the arc has to, make really small increments along the way. If it's on a lower resolution screen, maybe it's, bigger, fatter pixels, can do it larger. If it's going to a printer, the printer might have 300 dpi or who knows what. If it's going to a PDF file, the PDF file will have some resolution associated with it. Okay, so the context determines which of those things. Now, we're only going to talk about the screen today. We might touch on some of these other ones, especially off-screen bitmap. Actually, I'm going to talk about that briefly today too. But that's what context is about. For normal drawing, 99% of all the drawing you're going to do, the UI kit sets up this context for you. Okay, and it's set to be your current drawing context. And then you're able to call a function that gives you your current drawing context. This context changes each time drawRect is called. Okay, so the UI kit will set up a new context, call your drawRect, and then the next time it's going to call your drawRect, it'll set up a new context. So you never want to cache that context. You never want to hold it in an instance variable or static. You never want to keep it. All right? You always want to use the new one next time it comes around. We'll show you how to get the new one. And this is how. You call this function UI graphics get current context. And it will return to you this thing called a CG context ref, which is just this opaque type. You don't know what it is. It's a pointer to something. And it represents the context. And then you just use that context when you want to do all this line drawing and path building and stuff like that. You pass the context as an argument. So this is how you do that. So we're going to define a path here. First, I say begin path. I pass the context that I'm drawing in. Then I move around. So here I'm making this triangle up in the upper right corner. So I'm moving to a certain point, then I'm adding a line to a point, adding another line to a point. I only added 2 lines, but now I'm going to close the path, which is going to add that 3rd line, because it's going to make the path go back to its start. Okay, so that's a common graphics thing, to be drawing a path and then just close it and have it goes back. You don't have to close it, okay? Not strictly required. And then I set any graphic state I want, like the fill color and the line color. Notice that these are object-oriented methods, the UI color methods. We'll talk about those in the next slide. And then I call this method CG context draw path, and it takes the context and then a constant, in this case k CG path fill stroke. You're going to see that the constants in the UI kit and core graphics have the little k in the front. So this particular constant means fill and stroke the path. In other words, stroke it with the red line and fill it with the green. Okay? And there's other constants, and all this stuff is documented. I'm not going to go over all that today, but obviously you could just fill or just stroke. It's also possible to build up paths and hold them around. Like you might build like a star path and then just draw a whole bunch of stars. Okay? That you can do that as well. A bunch of C functions look very similar to the ones on the previous page, but they start with CG path instead of CG context. We're not going to go into that today because we're going to be time constrained here. The color class, it's pretty straightforward and obvious here. It has some predefined colors like red color, blue color, green color, which are class methods, which will return you a color. You can also make custom colors by specifying the RGB, or there's other mechanisms as well. Note also that there's alpha. See that alpha, the fourth argument to creating that custom color? That's transparency. Okay, 0 fully transparent, 1 fully opaque. So you can have partially transparent colors. Now you can start to see how if I have these overlapping views, you can see through, not just see through clear, but see through, with a little bit of rose-colored lenses maybe, okay? And then you just call set fill, or there's also set on color, which sets both the fill and the line color to be that color, all right? So more about drawing with transparency. Not only can you use the alpha, like above, you also can set a view property called opaque, all right? Well, first let me talk about the background color. So a view has a background color, which it'll fill itself with if you set it. That can be partially transparent. It also has a property called alpha, which you can set, which makes the entire view more or less transparent. Right? So you can use this to make views fade out over time. And we're going to talk about how there's API in the UI kit for animating alpha changes and things fading in and fading out. It's really cool. But if you're going to have a view that's not opaque, you need to set this opaque property, right, to no. Okay? Otherwise, the UI kit's going to try and optimize the drawing of it, and it's going to make some assumptions that are going to be wrong, and it's going to look funny. So anytime you have a view that's drawing transparently, not filling every pixel basically with an opaque color, then you need to set this thing, opaque equals no. Right? By default, it's yes. All right? Graphic state. So there's a bunch of C functions to set other graphic state, like line width. You can set the pattern that you're going to fill with. We're not going to go over that today. You just look that up in the doc. There's tons of them. All right, a special consideration really quickly, if you have a drawing subroutine, so you're calling some method to draw some sub thing, like a circle, like we're going to do today. When you do that, you want to push the context that you're currently drawing in onto a stack, set all whatever graphic state you want, draw whatever you want, and then pop the original one back on to be your current context. Otherwise, you might call a draw green circle method from some other method, and it's going to set your fill color to green. And when you come back, now your fill color is green. You don't want that. You want your fill color to be whatever it was before. So here, I set my fill color to red. Then I called this draw green circle. When I come back and I fill stuff, I expect it to still be red because I want that function to be kind of totally its own thing. Does that make sense? Right? So that's why we do this pushing and popping. And we're going to do that today too. Even though in our example we don't need to push and pop, we're going to do it anyway, just to show you. Last two things here is drawing text and images. So to draw text, the best way is to use a UI label. It draws text really well, has lots of options, does a really good job of it. But if you need to actually draw text in your custom draw rect for some reason, like maybe you need the text to be rotated somehow, or it can't really sit as a subview in your view, then it is possible to draw text, and here's how you do it. First, you need a font object. Okay, because you have to specify what font you're going to draw with. And there's a lot of ways to do it. System font, you can get a font by name like Helvetica. You can get the list of available fonts on the system and then pick one out of there. But you get your font from the font class. And then, this is very counterintuitive, but you actually send a message to the string object you want to draw, telling it to draw itself. All right, so for example, here I have the string object text, which I got from somewhere. And I send it the message draw at point, which is going to be, by the way, the upper left corner of this block of text, with font, the font I want to draw with. You can also find out how much space that text is going to use before you draw it by using this text size with font method on NSString. Now, as I said up here, you might be disturbed that string, which doesn't seem like a UI object, has these methods in it. And the answer is those methods don't come with string in its original implementation. They're added by UIKit, and there's a mechanism in Objective-C, which you can look up if you want, called categories, which allows you to add methods to objects without subclassing them. Okay, be careful of that. This is just a good time to mention it because this is such an egregious, obvious example of doing that. But that's how NSString does that, adds these drawing methods. There's some other ones too, draw in rect, things like that. All right, so drawing images. So just like with UI label, there's a great object called UI image view. It does a superlative job of drawing images. But if you feel like you can't use it as a subview, you can't fit it in there, the way you draw images is you create them first, and there's a bunch of ways to create an image. The easiest way is to put a JPEG file or something in your resources folder in Xcode, and then you can just call this method, UI image named with the name of the file, and it'll go get that image, which is kind of cool. But you can also create them from files. So if you have a path to a file, which we haven't even talked about how you get paths to files inside your application, but we will talk about that later. Or if you got data like from the internet, you can't talk to Flickr or something and you use Flickr's API to download an image, you'll just get the JPEG data, and you want to be able to create an image from that. So you can do that. You can even draw. I told you about contexts, which were bitmaps, basically drawing to a bitmap. This is how you do that. You call this UI graphics begin image context, and it will create a context, it'll change the current context basically to be an off-screen bitmap. And then you can just draw in it with CG, add line to, all these things. And then you just say UI graphics get image from current context, and it will grab that image that you just drew and turn into a UI image object. Once you have this UI image object, then you blast its bits onto the screen using either draw at point, draw in rect, or draw as pattern. Okay, one just draws it at a certain point, one scales it to fit into a rectangle, another one tiles it inside the rectangle. Okay. Just as an aside, if you have a UI image, you can actually get its image data as a JPEG or as a PNG file using these two functions. Kind of fun. All right, so that's a way you could actually draw an image, get the JPEG thing, save it as a file. You could create a JPEG with a custom drawing in it. All right, before I do the demo, let me talk about next time. So on Thursday, I'm going to talk about the application lifecycle, what happens when your application launches, what methods are getting called, how is all this view controller stuff getting created. And then I'll talk about the view controller lifecycle. We already talked a little bit about it with view did load and view did unload, but there's a lot more to that lifecycle, what happens from the beginning to the end of a view controller's life. And then we're going to talk about a very important new view controller called a navigation controller, which is a controller of other controllers. And then we're going to start having these MVC models that point to other MVC models. Okay? And we're going to start building more complex apps MVCs out of MVCs. So we're going to start doing that on Thursday. So today I'm going to do a first demo, and I'm going to do another demo on Thursday. Today's demo is called Happiness. And it basically shows an amount of happiness with a smiley face on screen. So the smiley face will be smiling if he's very happy. He'll be frowning if he's very unhappy. As always, I'm going to try and show you tell you about the model, the view and controller of our app. This application has a very simple model, which is an int. All right, that's its entire model. It's the happiness. I decided happiness went from 0 to 100. Okay, 0 is very, very, very sad. And 100 is very, very happy. Okay, so that's our model. I want to keep the model simple to keep the demo simple. That's it. Our view is going to be a slider to set our happiness, and a custom view, which is the face, which is going to show our happiness. Okay, so that's our view. And then we have a controller, happiness view controller. That's where, that we're going to do all what we always do in a controller, mixing all this together. As I do this demo, here's things to watch for. UI slider is new. We haven't shown you UI slider before, so you can see what I'm doing with that. Obviously, draw rect. I'm going to implement a draw rect to draw the face. Note how face view delegates its data ownership using a protocol. Okay, my face view doesn't want to own its data of the happiness or even of the smiliness. Okay, it doesn't know anything about happiness actually. It only knows about smiliness, whether you're smiling or frowning. But it wants to delegate that to someone else because that's its data. All right, and we talked about views don't want to own their data. Also, you're going to note the set needs display I'm going to use to make it so that the face gets updated as the model changes. And I'm going to show you this memory management syntax with these IB outlets. Okay, so you're going to see all that. All right, so here we go. This is speed demoing again, just like last time. So we're going to start from scratch as we usually do with our demos here. It's hard for me to type here with my listening my way, but all right. Where's my mouse? Mouse is not working. Okay. All right. So I'm just going to go to Xcode. Here's our splash screen. I'm going to create a new project. Let's create that. I'm going to do a view-based project again, as we always do, so it creates a view controller for me and a zip file with a view in it. I'm going to call this happiness. All right, so as usual, here's our classes. I'm going to make this big today because I have some wide code lines to type. Put this up here. All right, so we have our view controller, as usual, and our app delegate, which we're going to talk about next time. And down here in resources, I also have the zip file. The first thing I'm going to do is I'm going to create my custom view. Before I even go do my controller or whatever, I'm going to create my custom view. My custom view I'm going to try and make as generic as possible. It's as generic a face view as I can possibly make. And when you do your homework number 3, you're also going to want to make as generic of a custom view as you can. So the way I create a view is I go to the new file, just like I did to create an object. But instead of NSObject subclass, this is going to be a UI view subclass. Okay, simple as that. Click next. I'm going to call this face view. So that's what it is. Now, I'm also going to put my face view up here with the rest of my classes. In face view, I'm just going to go right to the implementation here. You can see that it's given me a little bit of code here. Here's its designated initializer. I don't actually have anything to initialize, but I'll just leave this here. It doesn't hurt. You can see this weird self equals super kind of notation we talked about last time. Okay. And then down here is dealloc. All right, we're going to leave that because we are going to have to dealloc something. And then we have drawRect. So I'm going to uncomment out drawRect, and we're going to implement it. All right. Now for time saving, I'm going to, actually I don't like to do it, but I'm going to copy and paste a little code in a minute here. But first, let's get started with this method. The first thing I want to do is find the midpoint of my view, because I'm going to draw my face right in the center of my view's bounds. Okay, so this I want you to really notice that I'm using self-bounds, not self-frame or self-center. A lot of people would just say, oh, get my center. No, you don't want to use center here. You want to use bounds. So I'm going to say CG point, my midpoint equals, well, we'll just set them separately. So here's the midpoint. Midpoint.x equals self.bounds.origin.x plus self.bounds.size.width divided by 2, and midpoint midpoint.y equals self.bounds.origin.y plus self.bounds.size.height divided by 2. Okay, so that's how I find my midpoint. I don't call center or anything like that. The next thing I want to do is figure out how big I'm going to make my face. I'm going to make my face round, and I'm going to make it small enough to fit in whichever is smaller, my width or my height. So my view doesn't have to be square. It could be long and thin, but I want to make sure my round face fits. So I'm going to have a CG float here called size, and I'm going to actually set it to be my bounds.size.width divided by 2. I'm going to have my size be actually the radius of my face, the radius, not the diameter. But I'm going to check and see if my self.bounds.size.width. I'm also going to make sure that if my height is less than my width, then I'm going to set my size to be my self.bounds. Size equals self.bounds.size.height divided by 2. Okay, so I've basically made it so that size is the smaller of one of those two. And then the last thing I'm going to do is I'm going to make my face so it doesn't go all the way out to the edge. I'm going to kind of make it a little smaller. So I'm going to say size times equals 90%. Question? You mean this question mark colon? Yes, it does. It's C, right? So the question is, does Objective-C have the question mark colon operator? And yes, it does. I could have done that here, but I didn't. Okay, so now I have my midpoint and I have my size, which is my radius of my face. Okay, so I'm going to make this face simple to draw. I'm going to have a subroutine that draws a circle, and I'm going to use that to draw the face and also to draw the 2 eyes. All right, so now I need a subroutine. I just want to do that to show you how to do this thing with the pushing and popping. So first I need a context to draw in here, so let's just get that. UI graphics get current context, because you're always going to do this towards the top of every draw rect is get this thing. And then I'm just going to say self draw circle at point, midpoint, with radius size, context. All right, now I have to implement that little method. So that's void draw circle at point, takes a CG point, P, with radius, we'll call that CG float radius, context, CG context ref, context. Okay, so the first thing I'm going to do inside this thing is UI graphics push. I'm going to push my context onto a little stack so that I can make any changes to the context I want here and not affect whoever's calling me. So I'm just going to begin a path, CG context, begin path with our context. Then I'm going to CG context add arc. Now arc takes a context and then it takes the starting angle and the ending angle, and I'm going to draw a whole circle. So I'm going to start at this, it wants the center, so I'm going to give it p.x and p.y, and then the radius is radius. The start angle is 0 and the end angle is 2 pi. So I'm going to go all the way around the circle. Okay, this is in radians. Everyone understand what radians are? So 2 pi is all the way around the circle. And it doesn't matter whether I go clockwise or not, I'm going to go clockwise. Okay, probably say yes there too. It says an int, but probably yes would be better. And then that's it. So now I'm just going to stroke that path. So I say context stroke path, context, and that's going to stroke it. Now you might say, well, what's my line color and what's all this? That's whatever the default is. And UIKit sets up reasonable defaults when it calls your draw rect. Usually, black and line width of 1, those kind of things. So we're going to let that be that. For now, we're going to let that, and we'll change it maybe later if we have time. And then I have to pop that context back to put things back the way they were before I did anything. Now, I didn't actually do anything because I didn't set any line widths or colors or anything like that, but it's still good to get in this habit. And later I might come back and change something in the middle here, and if I have this push and pop, then I'll be saved from damaging myself. All right, so now I'm going to copy and paste in the code that draws the eyes and the mouth, which I have right here in this little file. And you can look at it at your leisure. I'll obviously be posting all this. It's pretty straightforward. It mostly involves calling draw circle for the eyes, right? Just picking some round circles and calling my draw circle method again. And then the mouth, I use a Bezier curve, which I have to specify the beginning and the end and 2 control points, and it basically draws 2 tangents and then draws a line that marks to those 2 tangents. That's how I'm going to get a mouth. I'm not going to do this yet. And so now so this is all the mouth start and mouth end and control points. So now I'm actually going to call the CG context things to draw the mouth. Okay, so I'm going to start with begin path as usual, context. And then I'm going to do move to point, and I'm going to move to mouth start .x and mouth start .y. And then I'm going to do this Bezier curve, which is, what do they call this thing? Add curve to point. You can see there's all these things. There's the context. There's my mouth control point 1.x, mouth control point 1.y. Here's mouth control point 2.x and mouth control point 2.y. And then x and y is the end with this mouth end.x and mouth end.y. And so I've moved to the start right here, and then I did a curve to the end using these control points. And then I simply CG context, stroke path, context. Okay, and that's it. Okay, so that's the implementation of this. See if we have any errors here. Probably typed something wrong in there. In context. Just context. Okay. So now I have this custom view. Let's just go into Interface Builder real quick and add that custom view. So I'm double clicking on my interface builder file. Here it is. I'm not going to have face view in my library here anywhere, but I do have this guy, which is generic UI view. So I drag that out here. Let's make it smaller. I don't want to take up the whole space. We'll use the blue lines to line things up. So, yeah, something like that. And then I'm just going to go to the inspector. And if you look in the rightmost column of the inspector, that's the identity inspector, you can see it says class identity class. And right now it's a UI view. But I'm just going to click here and change it to face view. Now Interface Builder knows about face view because it's in my project, right? So it can see classes in my project. So I hit save. That's all I need to do. Go back, build and run. And we have a smiley face. Woo! Okay. So that's good. Okay, we're getting there. We're probably going to run out of time. We might continue this on Thursday, actually. So the next thing we need to do is make our face view's smiliness controllable. Okay, and this is what I'm going to do with this protocol. All right, I'm going to use a protocol to do this. So let's go to faceview.h and show how we would define this protocol. So I'm just going to say @protocol to define it, and I'm going to call it a face view delegate because it's the face view delegating something, and then here it wants the method. So I'm just going to have one method, which is a float, which is the smile, and I'm also going to say for face view star requester, and I'm just going to pass myself along. And usually delegate methods do this. When they delegate some information, they pass themselves along as an argument so that questions could be asked of this face view. We don't need to in this case, but notice also that I'm using face view here, but it's not declared yet. It's not declared until down here. All right, so that's a problem. We'll have to resolve that in a second. So now I need my delegate to be a property, so I just say property, and I'm going to make a sign, because I'm going to be assumed I'm owned by a controller or someone longer lived than me. And I'm going to say ID face view delegate, my delegate. Okay, and now I need an instance variable for that. Same thing, ID face view delegate. All right, and so I have this problem where this is not declared. Now, unfortunately, I can't move this up higher in my class so that this will be declared because I'm actually using this right here. So it's kind of they refer to each other. So how am I going to resolve that? And the answer is you use a forward reference. Those of you who know C will be used to that. And I'm just say @class faceview. That says to the compiler, there's a class. Faceview is a symbol that means it's a class. I'm going to define it later. All right? So that's how we deal with that conundrum. All right, so the next thing we need to do is go back to faceview.m. Let's synthesize our delegate. Okay. We don't need to release our delegate because it's assigned, right? So there's no, we don't own it. We don't take ownership of it by sending it retain or anything. So we don't need to release it, so that's all good. And so the last thing we need to do is just use our delegate. And the way we're going to do that is we're going to say self delegate smile for face view self. Okay, and that's going to return times. Smile for face view delegate. Now you might say, well, what does that smile mean? And so I better put some comments in here. I'm going to say -1.0 to 1.0. Okay, and this is a smile, and this is a frown. Okay, now if we had more time, I would probably bounds check my delegate to make sure my delegate wasn't returning -20 or something like that, because that would make my smile look terrible. But we don't have really time for that. In fact, we have 2 minutes left. Okay. So I think we're good there. Yes. Okay. So now we have a face view. It's a generic face view. It doesn't know anything about happiness or anything like that, but it's set up so that when we build our controller, we'll be able to control the smile, how much it smiles, etc. All right. So I'm going to get as far as I can in my controller, and we'll see how far that is, and then we'll continue on Thursday. So the first thing I want to do in my controller is let's do the whole API. Basically, what is the API of our controller? And so we need our model, and we need our outlets, and we need our actions, things like that. So our model is easy. That's happiness. Okay. I'll put a comment here, 0 to 100. Outlets, I'm going to need two outlets, one for the slider and one for the face view. So I'm just going to say UI slider star slider, I'll call it, and face view star face view. Okay, I mistyped. That's got to be lowercase a. And I've got to import face view here to do that. And then I'm going to do my outlet properties. Property, retain, IB outlet, UI slider, star slider, and @ property, retain, IB outlet, face view, star face view. Okay, and then I have one action, IB action. Happiness changed, I'll call it, which is the UI slider is going to send to us. Okay, so that's my entire API. We're pretty much out of time. What I'm going to do on Thursday, I'm going to implement this controller. So I'll implement all this connectivity between it and the face view. That's basically all I'm going to do on Thursday. So I'll do that at the beginning of Thursdays. Then we're going to get some slides on all that life cycle. And then at the end, I'm going to write another app that's actually going to use this model view controller in its implementation. It's going to have its own model view controller. It's going to use this. All right? So that's it for today. Thank you.
For more, please visit us at stanford.edu.